everyone, welcome to Chemistry 101, and today we are going to be learning about chemical reactions. And I'm sorry to jump right into it, but I don't really want to be here right now, as most of you probably feel the same way. But anyways, does anyone know how many types of chemical reactions there are?
There are 5.
5 chemical reactions. There are 5. The first one is a synthesis reaction. It's kind of hard to say. Anyways, it's a synthesis reaction, and does anyone know what a synthesis reaction is? You.
It's an element plus an element to make a compound.
Exactly. So you're just going to see 2 elements and it yields a compound. Pretty self-explanatory. Pretty easy. The second one is a decomposition reaction. Does anyone know what that is? Yeah.
Okay, it's when a compound breaks down into its individual elements.
Individual elements. Pretty much. Decomposing means to break up, and it is breaking up. It just means a compound breaking up into 2 elements. Now we're going to take a break. I'll be right back, everyone. Bye-bye. Okay, everyone, we're back, and the next type is a single replacement reaction. And does anyone know what that is? Anyone know how to say it? Okay, no one knows? I'll do it myself. It is when one element trades places with another element within a compound, and it's going to look like an element plus a compound yields a new element and a new compound. The thing that is tricky about this is, does anyone know? Anyone know?
Oh, you do know? Okay, so the element has to be more reactive.
More reactive, exactly. The element that is by itself in the first place needs to be more reactive than the element within the compound that it is switching with. So, it's pretty simple. Does anyone know what the opposite of a single replacement reaction is? Gary, do you know? Oh, no? Okay.
A double replacement.
Double replacement reaction, that's what it is. And it is when 2 compounds sort of switch partners, like a rodeo. I used to be in the rodeo a long time ago. But anyways, it's when they switch partners and they form 2 new compounds. So it's going to look like a compound plus a compound yields a new compound and a new compound. Pretty self-explanatory. The one thing you need to do about this is there's another little tricky thing. Does anyone know what the little trick? Okay, yeah.
Okay, so at least one has to be a solid. So if there's no solid, there's no reaction.
No reaction. Ixnay on the reaction A. Okay, let's take another break. Bye. Yeah. Okay, hello everyone, we're back, and the last type, there's only one more, and this one is one of the easiest. All you have to do is just memorize. Retention is key in this class. Let me just warn you. You need to memorize everything, and when I say everything, I mean everything. So anyways, the last type, does anyone know what it is? Anyone? Cindy? Sandy? No? Okay.
Combustion.
Combustion. That's what it is. Yeah, it's a combustion. And pretty much what this looks like is when oxygen combines with the compound to form the same thing every single time. Water and carbon dioxide. H2O plus CO2. Pretty simple. Just got to memorize H2O plus CO2. Remember, retention is key. Retention is key. Okay, so that's the last thing. And tomorrow we're going to be learning about something that's a little bit lengthy, a little bit hard, a little bit more advanced. Gary, I'm talking about you. You might want to study tonight. I'm going to be handing out sheets right now about oxidation numbers. You're going to need to memorize that for tomorrow, pretty much. Memorize, you know. Anyway, so I'll see you all tomorrow. Bye-bye.
Bye.
Yeah, bye. Hello, everyone. Welcome back to Chemistry 101. Second day, we're learning about redox reactions. It's kind of lengthy, so I'm going to talk fast. Hope you don't mind. Gary, I'm talking to you. Okay. The first step in balancing a redox reaction is to find the oxidation numbers of the elements. I already gave you the sheet on that. You should have memorized it. Retention is key. Yeah, she has retention. Anyways, so after we find the oxidation numbers, we're going to have to find out which one is being oxidized and which one is being reduced. And I have a little mnemonic memory device that is Leo the Lion says grr. My old chemistry teacher taught that to me a long time ago. But anyways, yeah. So here we see that N is going from +3 to +5, so it is losing electrons, so it is being oxidized. And how I remember that is Leo, the lion says grr. And here we see Leo losing electrons, it's being oxidized. And the next part, we see Mn is going from +7 to +2. It is gaining electrons, so it is being reduced. Grr. Gary, is that a Christina Aguilera ringtone? Give me the phone. Oh my God. Okay, anyways, now that Gary's phone is off, Gary, after you find out which one is being oxidized and reduced, you split them into half equations. Half equations, I'm sure she was going to say that. N is being oxidized, as we said, and so we split the N's into a different half equation and split the MN's into another half equation. Okay, and after you do that, you balance the oxidation numbers by adding electrons. Yeah. Anyways, so here we had plus 3 was an oxidation number, and plus 5 was an oxidation number. And if you knew basic math, which Gary you should know, which you don't, you would know to add 2 electrons to make it even. And after you add the electrons, you balance the overall charge of each half equation by adding
hydrogen ions.
Hydrogen atoms, not ions. I'm sorry, you're wrong. Anyways, so you see here we had an overall charge of -1, and over here we had an overall charge of -3. So again, if you knew basic math, you'd know to add 2 hydrogen atoms. Wow, she was wrong for once. That's pretty surprising. And then you balance the hydrogen atoms by adding water. So since we have 2 hydrogen atoms, how many waters would you add?
Well, since it's H2O, you would add 1.
1. So on the other side, we'd add 1 hydrogen atom.
May I go to the bathroom?
She has to go to the bathroom. We'll just take a break. Now that Missy Smarty Pants over here is done in the bathroom, we're going to keep going. And okay, after we balance the hydrogen atoms with water, we are going to balance the number of electrons by multiplying by the least common multiple on each side, or to get the least common multiple, I should say, for you dumb kids. What? Did I say that? Oops. Anyway, so as you see, we have 2 electrons in this half equation and 5 electrons in this half equation. And what is the least common multiple?
10.
10. Okay, so we multiply 5 by here and 2 by here to get 10 electrons. Make sure you multiply everything, everything, everything. Multiply everything. Do I need to say it again? I hope not. Anyways, so after you multiply everything, you simplify. But make sure oxygen is balanced, because if it's not balanced, you gotta go all the way from the beginning and do it again, and that's just a pain. No one wants to do that. Anyway, so after you multiply everything, again, check to make sure oxygen is balanced, simplify. You see, cross out the electrons, and you see we have 10 hydrogen atoms and 16 hydrogen atoms. Again, if you knew basic math, Gary, you would know to cross out the 10 hydrogens, cross out the 16, and leave it with 6 hydrogen atoms. That's all. Okay, and then after that, you simplify. Simplify everything, like I just said, and then you combine the 2 half equations to make one super redox reaction. Make sure everything is balanced, or else you fail. Pretty much you fail. Okay, so bye. Hope you all had a horrible day. Bye.